Hello everyone, thank you for joining our first information session here at Solvest for 2021. I'm joined today with Dr. Harry Penn of the Kluane Lake Research Station, and today we're just going to be discussing what's going on at his facility in terms of renewables and sustainability and the environment, and really just tying this all into World Earth Day that happened just last week. So sort of in celebration of that, we decided to have Harry on the show here to give a little insight into what's happening at the Kluane Research Station.
Thank you. Yeah, thank you for having me today and talking through the work we have going on. Yeah, this is good.
Excellent. So to start off, could you just describe to us and the viewers what exactly is the Kluane Lake Research Station?
So the Kluane Lake Research Station was started in 1961. We are 220 kilometers north of Whitehorse on the Alaska Highway on the southern shore of Kluane Lake. We're on the traditional territory of the White River First Nation, the Kluane First Nation, and the Champagne-Ajac First Nation. And we're a facility of 20 off-grid buildings that feature accommodation space, mess hall, wash house space. We have lab space, office space, storage space, teaching facilities, and just some beautiful outdoor spaces and grounds. The facility operates year-round and welcomes researchers and field schools, high schools, university groups from across Canada, the US, and Europe to the facility, and groups spend anywhere from a few days to a couple of weeks learning, researching, and enjoying the region.
That's incredible. That's quite the operation that you have.
Yeah, it's a lot of work, but it's also really enjoyable to be able to bring such a diverse group of people to the Yukon and to the Kluane region, and get to learn all about the really awesome research that they do on a daily basis.
So in a typical year, maybe pre-COVID, how many researchers would you have on site in a year?
Pre-COVID, we do somewhere in the region of 3,800, 4,000 user days, which is how research stations kind of measure their numbers. And a user day is basically a person in a bed for a night. Okay. And so for us, that represents 25% of those are researchers from Canadian, US, and European institutions. Around 70% are field schools. So that's everything from basically 8th grade through high school into university and graduate level students. And then the rest is either community events, film crews, other media outlets, that kind of work.
Fantastic. Excellent. So I know you guys have done a lot of research surrounding food sustainability in the north and starting research for fresh produce. Mm-hmm. Could you describe to us what's occurring at your research station in regards to hydroponic growing?
Yep. So in 2019, we were able to purchase a crop box through Solvest and Cold Acres here in Whitehorse, and we installed that at the beginning of 2020, and the unit's more or less in a position now. We sort of delayed the start of the project with COVID and everything else, more or less in a point where we can start operating now. And so the crop box is a 40-foot insulated shipping container that houses growing trays with enough space for it's just over 2,800 plants. Each tray of plants has got a row of LED growing lights above it. And so we'll be operating this unit, this facility, 12 months of the year. And the project really has two broad goals. The first is to really evaluate and understand the costs of having one of these systems in a northern off-grid setting, as opposed to a more urbanized setting where they're typically more often used. And so to be able to do that evaluation and provide that information to anybody else in the north, communities or organizations that are looking to invest in this type of technology for their community or for whomever, business or whatever, and so provide all that information. The second part of the project is to really try and expand the types of produce and crops that are being grown there, but more specifically to work out a growing cycle, I suppose, that matches what people in our local region and in communities nearby want to eat at certain times of the year. and so be able to sort of address, I suppose, food security in its broadest possible sense from that direction.
Excellent. Yeah, I know with the pandemic, a lot of people, like hobby gardeners, have really increased drastically in the last couple of years, and food security across the globe is such a huge issue now, especially when you get into the north, when transportation costs and if the highway is out for any reason, you could have grocery stores go pretty quick empty. So have you been able to distribute any of that produce, or have you actually started growing that?
So we're going to start growing here in the next month, and then the goal is to distribute basically all the way to the north end of Kluane Lake, so about 8 kilometers or so up the highway, and then similar distance south through Haines Junction, and kind of just basically the whole region that we sit in. So we figure it's around 3,000 people that we'll be able to distribute to. And that will be on a weekly basis, kind of very similar models to how other hydroponic systems are operated in a community setting. And what's going to be interesting, I think, is to see, lots of people, as you say, have gardens and greenhouses that they operate in the summer, so presumably a lot of leafy greens coming out of there, herbs and so on and so forth. They're probably growing root crops as well, which they're going to store in some form or fashion over the winter. And so from our system's perspective, what are we trying to support here? Are we just providing more leafy greens in the winter when they're harder to grow, traditionally in gardens or greenhouses? Or are we adding more volume in the summer to things that people are already growing? So I think one of the main goals of this project is to really understand that. Because gardens and greenhouses have more than just a functional reality, right? There's cultural pieces, there's fun pieces. It's great to get kids and schools involved in greenhouses and gardens. Putting your hands in dirt is a fun activity. These hydroponic systems have the benefit of being able to grow year round, but truly, how do they sit in that broader landscape and actually have meaning, I think, is the question.
And what do you see? I know a lot of the crop boxes and hydroponic facilities across the world are grid connected, and they might go directly to a specific hotel's restaurant or something like that. What do you see the challenges of having this facility completely off grid, and how are you addressing those challenges?
The first challenge, and there's no getting away from it, is you have an increased capital expenditure. It costs more to run one of these systems initially because you have to buy the system and then you have to buy the off-grid setup. That said, we are not now contributing to any increased diesel consumption at the research station. We can demonstrate that these systems can run year-round off-grid. I believe we can, and so in so doing, northern communities or northern areas can take on one of these systems, knowing that it's not going to be an additional diesel cost. It's not going to be more wear and tear on generators necessarily, or just the environmental consequences of having one of these systems are perhaps reduced by running them off grid. And so I think there's something quite nice about growing hydroponically in an off-grid setting. We're trying to produce nutritional food, and so we're doing that in the most sustainable way possible, which is by using renewable energy.
And I guess that ties nicely into the next question. How has solar been integrated into your facility over the years, I guess, being from 1961 onwards? Was there solar research done earlier when solar was a new technology? I know you guys have quite a system now, but maybe kind of take us through that renewable energy strategy and timeline.
Yeah, so in the north we have an abundance of sun in the summer. A little bit more challenging in the winter maybe, but certainly in the summer we have an abundance of solar potential. And so the research station, I think pretty much since the technology was really economical, was feasible, has had small patches of solar. And so maybe that's just a small battery bank that keeps a little bit of critical infrastructure up and running. Certainly a lot of our researchers, if they are installing instruments in the field, will take solar panels and batteries with them, and that will help support a weather station or something like that. What we've progressed into now over the last couple of years at the research station is a far more widespread whole-scale renewable energy system. So we now have 128 440 watt solar panels that are spread out across 2 building roofs and 2 ground mounted racking systems. We have 44 2-volt batteries. They're the gel lead acid batteries, so they can work at extreme colds. They can hold a charge for a long time at extreme colds. And then we also have all of that connected to our existing generator. So the way that the system runs now is that for pretty much from Valentine's Day onwards, we're using a mixture of the solar panels, batteries, and just direct solar. Skip the batteries entirely. And then by the time we come around to Halloween, mid-November, something like that, we are using a mixture of the solar panels again, the batteries, and then when we are without solar, the generator turns on, charges the batteries, and then we go back to using the batteries themselves. The advantage of using that system is that the generator is on for the shortest possible time, running at the highest possible load, and so the generator is happier because it's actually managing a load. We get more fuel efficiency, we lower our emissions, and then we can return quickly to the batteries after about 6 hours. And then for most of our winter operations, those batteries run for 18 to 36 hours, depending on what's going on. And so what that has done for us, to put some numbers to it, is in 2019, we spent just over $30,000 on diesel. In 2020, we spent just under $4,000 on diesel. And so that's really helped support the research station be a more sustainable operation, and demonstrate this technology in a northern context, and just be a more kind of, as I say, sustainable operation and a nicer place to be. It's quieter. We don't have a generator ticking on all the time.
Yeah, absolutely. And I think a lot of people don't realize, even without solar integrated, even if you just had a battery bank that was able to be charged with a generator that's operating more efficiently because it's at a higher load, and then being able to turn that generator off, you're reducing your runtime, you're reducing your maintenance costs with those generators. So there's a ton of environmental aspects, as you've touched on, but even just the technical aspects of things like that, right?
Yeah, when we're operating a research station that's got minus 80 freezers, minus 40 freezers, we've got all the foodstuffs, the kitchen, the wash house, we've got scientific equipment, we've got a dryer or a washing machine, these things with these high peak draws. You have to size a generator as if they're all going to come on at the same time, which conceivably could happen. But with the battery bank, we can manage that whilst also not having to run the generator full time. So yeah, the battery bank was a huge win, I think, for the station.
Incredible, excellent. So I know briefly that you've started looking at researching mushrooms at your facility. Could you maybe discuss that and what's occurring with mushroom technology and innovation?
So as I mentioned, the research station's been around for 60 years. It's our 60th anniversary this year. And over that time, we have evolved. We've had fueling stations for airplanes, fueling stations for vehicles. We've started off with generators. We've had heating done by heating oil and other hydrocarbons and fossil fuels. And so over that time, there's been a little bit of here and there low-level contamination, low-level ground contamination. Historic, the station is, significantly more sustainable and cleaner than perhaps it was 30, 40 years ago, but nonetheless, this is the reality that we have. And so one of the main goals of this project is to really look for how bioremediation can be done in a sustainable way and in a hyper-local way. And so we know that there are flowering mushrooms around the research station, in the woods and so on. And so the goal of this project is to harvest some flowering mushrooms, collect their spores and create a culture and introduce that culture to low levels of contaminated soil and essentially train those mushrooms to consume the contaminated soil whilst they're flowering. And so what that will mean is that we create a methodology for anywhere where there is contaminated soil to harvest local mushrooms, train those mushrooms to be bioremediants themselves, to consume the hydrocarbons and clean the soil. And so what we have at the research station now is a unit that can grow mushrooms. We have some lab space that we're designating to this. A couple of researchers will be involved this summer and moving forward to start that process and start writing out the lab protocols. The ultimate goal of the project is to get a little bit more grant funding and create an enclosed trailer that's sort of half lab space, half mushroom chamber, with some solar panels and a little bit of energy. And then we can transport that unit around the Yukon and to wherever else there is contaminated soil and sort of get that process started so that these mushrooms can continue to grow and hopefully be successful, sustainable bioremediates. So that's kind of the plan.
It'd almost be similar to tree planting after deforestation
Totally.
or something
Yeah,
like that.
yeah.
Right?
So we know that a lot of plants have bioremediation properties. You can use willows or poplars. You can use more sort of local plants, so Labrador tea, something like that, will also work very well. And so this is our attempt to try and use it with mushrooms to see whether or not that works.
And has there been any research around the properties of mushrooms to absorb hydrocarbons and leach?
Yeah, so you can. There are numerous research papers and numerous studies that demonstrate that mushrooms have this capacity. Whether it's low-level hydrocarbons or heavy metals, there are mushroom strains that can do it. The trick with this project is rather than importing a mushroom strain that is not native to where we are or to the Yukon more broadly, is to actually see whether we can train local mushrooms to do it. Because then, as I say, they're already adapted to growing in that environment. What we're just trying to do is give them that sort of extra skill set to also grow in contaminated soil, and then we can put them back and potentially even grow in situ, rather than having to grow in bags in a mushroom chamber.
Fantastic, excellent. So you mentioned that you're celebrating your 60th anniversary at KLRS. That's fantastic. Congratulations.
Thank you.
What does the future look? What's the next 60 years, in your opinion, look like for the research station?
I think one of the goals for the next 60 years, I think, is to continue to demonstrate and to trial where as much as possible new and emerging technologies, and new and emerging in the sense that they are arriving in the north, that perhaps they're being used down south or in urban centres, and that there's potentially a chance that they would have validity and usefulness in the north. And I think the research station is a great test bed for trialing those and putting them out there so that the public and whoever else can come along and see, and we can give information about them, we can run trainings on them, we can be involved in their development. I think that's going to be a huge part of where the station wants to go. And then other than that, it's just going to be continuing to welcome new and exciting research to the Yukon and hosting it and being part of it. Research that is meaningful to our region and to local communities, but also meaningful to Yukon more broadly. And then I hope that we can continue to build out our field school program and welcome more high school students, both from the Yukon and around Canada, and other university students, so that they get the opportunity to experience the really beautiful region of Kluane that we get to be in, learn about its science, its research, and its history and its culture, and then use that to kind of inform where they go next in either their teaching or their studying or profession or whatever it is. So I think those are the goals. Yeah.
And so when you're talking about bringing whether it's students, university students to the research station, do you incorporate any? I know you're located on the traditional lands of the White River First Nation, Champagne and Kluane First Nations. Do you incorporate any of those traditional teachings, or have elders or First Nation citizens come to the research stations to kind of share their local knowledge?
We often do. It depends very much on what the field school is hoping to achieve. A lot of field schools perhaps have got very strict syllabuses that they need to make sure they hit those teaching points on. But I would say more and more of our field schools are looking for that part of their education as well, that part of their experience. And so spending time in community or talking to community members, going to First Nation camps, that kind of thing, or just basically being in the region and just learning from people as they have interactions. I think all of these things we do work with field schools on a one-to-one basis to try and integrate those kind of learnings and activities and into it, because I think it really supports the more westernized science education that they're getting, to have that local cultural perspective as well. I think the two just reinforce each other.
Absolutely. And yeah, maybe just to tie everything together, the Kluane Research Station has been around for 60 years, and I'm sure you've seen, being so far north, the effects of climate change over those 6 decades. Have you noticed anything at your time there, or has the data shown anything that that kind of supports the climate change, what's occurring in the north, and is there any extreme examples that you could offer, any insight?
Yeah, I mean, I think the most extreme example, I think it's been reasonably well documented now, is the steady withdrawal of the Cascos Glacier that led to its toe, its front of it carving off, and blocking up the IE2, the Slims River Valley, and that has resulted in a drop in Kluane Lake in the lake level, some 9 or 10 feet. I think is the number that most people use. That's one extreme example. I think more broadly than that, researchers have been documenting over the last 20 or 30 years changes in boreal forest, changes in shrubification and tree species. We're seeing different animals come now into the region, deer and things like that. I think there's a general steady trend of change that is linked to climate change, and we've got researchers tracking it, everything from mammalian and boreal forest science, all the way through to the glaciers and the ice fields, lake chemistry and things like that. But it's definitely something that I would say that the majority of our researchers have at least one eye on when they're conducting their research.
Yeah, fantastic. Excellent. Well, I think that kind of wraps up the interview, but thank you very much for joining us today and being the first guest of our 2021
Thank you very much.
sessions. And looking forward to seeing what you guys accomplish in the next couple of years, and hopefully Solvest and Cold Acre can continue to be a part of your journey and provide some expertise on that renewable front. And very exciting stuff.
Yeah, it is an absolute joy, and I think it's hugely important for the research station to have local Whitehorse, Yukon-based partners like Solvest with the technical expertise and the knowledge that they have, that we are not going to be the sustainable facility without that support that we get from Solvest. So no, thank you.